Now, let's discuss the problems from yesterday. So, let's start with the first. So, the first problem is we have a planet X with a gravitational field strength of 18 newtons per kilogram at its surface. Planet Y has the same density as X but 3 times the radius of X. What's the gravitational field strength at the surface? Now, the right answer here is letter C. Now, let's show how to do it. So, basically, the condition is we have here a planet X with a radius r, and we have planet Y, which is 3 times its radius. Both of them have the same density. So in order for us to know what will be the gravitational field strength of planet Y, we have first to use the formula. Gravitational field strength is equal to the universal G constant times the mass over r squared, where r is the distance from the surface to the center, which is relatively equal to the radius itself. And since the condition says that uh, x and y have the same density, this means to say that the density also affects what will be the gravitational field strength of this planet, because density is equal to mass over volume. Now, since we don't know the mass of planet Y, we can simply um, isolate mass from the formula density mass over volume, which gives you density times volume. Therefore, the mass here, we will just replace it with dV. Now, um, as we said, your planet Y is also dependent on the volume, and the volume of a sphere is directly proportional to its radius. As you can see, V is equal to 4 pi r cubed over 3, which is the standard formula for a sphere. Therefore, we just substitute your volume here with 4 pi r cubed over 3. Now, going here, as you can see, we cancel the density here because first, uh, they have the same density. It doesn't really matter. Therefore, simplifying, this gives us this equation. And we know that planet Y has 3 times the radius. Therefore, we replace r cubed here with 3r. Also, the r squared, since we're talking about planet Y, will be replaced by 3r as well. Now, we neglect g and 4 pi over 3 since these are standard values or standard rotations of these quantities. Thus, the remaining quantity will be 3r cubed over 3r squared. And simplifying, eventually this will give you gy is equal to 3, which means to say 3 times the gravitational field strength of planet X, which is 18. 18 times 3 is equal to 54. So this is the answer for the first problem. Now for the second problem, the given is we have a planet, and this planet has two satellites orbiting the planet itself. So we have satellite X, where the distance between the planet and satellite X is r, whereas your satellite Y has a distance of 2r um, between the planet and its satellite. Now, from the given conditions, the mass of satellite X and satellite Y are equal. And what we have to find is the ratio between the centripetal acceleration of X and centripetal acceleration of Y. So for us to solve that, we know that the centripetal acceleration of any given body in circular motion is equal to v squared over r. Since we are talking about the ratio of x and y, we just substitute v squared over r for x divided by v squared over r for y. Now, we also have another formula for v because v here is the velocity and r is the distance or the radius. So v is actually equal to the square root of universal constant g times mass over r. Therefore, we can just substitute this quantity and replace v with g square root of gm over r squared divided by r for x. Of course, we also have to do the same thing with y. Thus, if we simplify these equations, this will result to gm over r squared x divided by gm over r squared y. Now, we cancel out the like terms. Well, it's obvious that the like terms are g, so we cancel out g. We also cancel out m, they are like terms. This will leave us with r squared y over r squared x. From the given condition, if we're going to go back, your satellite y is 2r. So therefore, replacing the equation here at the bottom, we can just say 2r squared over r squared for x. Then we cancel the radius. This gives you or leaves you with 2 squared, which is equal to 4. So the answer for that problem is 4. Now going to the problem, which graph shows the relationship between gravitational force F between 2 point masses in the separation r? Now the right answer here is D. Let's discuss first A, B, C. Well, B cannot be because this only talks about R and it's not equal to what the gravitational force between two masses shows. So B eventually is taken out. A also is the same as this because it says here that when you apply a greater force, the distance is like the force decreases as the distance increases. Which is not relatively what the expression is all about. Letter C is also not possible because it says here gravitational force is directly proportional with the inverse of the distance, or in other words, force increases as the inverse of the distance also increases, which is also not the expression. Going back, we know that the gravitational force between two masses is equal to Fg is equal to g universal constant times mass 1 times mass 2, all divided by the distance, the square of the distance between these two masses. So in order for us to know the relationship between your R and Fg, or the gravitational force, we just have to take out the quantities that are not related, which is g, m1 and m2. We take it out of the system, or out of the equation rather. This will leave you Fg is equal to 1 over r squared. Now the equal sign, we just replace it with the proportionality sign, which indicates that the gravitational force is directly proportional with 1 over r squared. Now the direct proportional sign tells you that as force increases, the inverse of the square of the distance, or 1 over r squared, will also increase. Or in other words, there must be a straight line that will come out from the point of origin, or from the start, which should be directed upwards to the right. We go with the last question that I will discuss because the question number 5 is not really difficult. So as you can see the problem here, we have two isolated point particles of mass 4m and mass 9m, which are separated by a distance of 1 meter. A point particle of mass m is placed at a distance from the particle, or in other words, there's a particle of mass m in between 4m and 9m. Now, the net gravitational force on this point is 0, or in other words, at this point, 4m and 9m will have the same gravitational force. Because when we say it's 0, this means to say these two bodies are in equilibrium. So they are experiencing equal forces. Now, it's also in the problem that your x is the distance between point M and 9m, whereas for us to get the distance from 4m and m, we just have to find the difference between the total distance between these 2 points, which is 1 meter, and the distance from the right side. So 1 meter minus x will be the distance between 4m and the point particle. Now, to solve the problem, as I said, since we're talking about equal forces, we equate the gravitational force experienced by 4m with the gravitational force experienced by 9m. Therefore, we substitute g times 4m r squared. As you can see, we did not include the mass anymore of the second mass here because they will cancel out. So to simplify it, we do not put it in here. We simply know that we have canceled these masses. So G 4m over r squared is equal to G times 9m over r squared. Now we cancel the like terms. So like terms is G and M. After that, it will leave you with 4 over 1 minus x squared is equal to 9 over x squared. We cross multiply, so this results to 4x squared is equal to 9 times 1 minus x squared. After that, since this has an exponent, this means to say that we have to expand this expression. This will give you 1 minus 2x plus x squared. Then we distribute 9 to the parentheses, so this gives you this expression. Finally, since we know that there's x squared, this is a quadratic equation, a quadratic function. We isolate, we transpose 4x squared to the right side. Eventually, this will give you a final expression of 9 minus 18x plus 5x squared. Now, you can actually use the quadratic equation, quadratic formula to get what is x. But in my case, I think it's easier for me to factor out this expression with x minus 3 times 5x minus 3. Now, equating that to 0, we know that x will be equal to 3, and the other expression is 5x minus 3 is equal to 0. Simplifying this will give you x is equal to 3/5. Now, if we go back here, well, there is no option for 3 meters. The only option is 3 over 5. That's why the answer for this problem is letter C, 3/5 meters.